Well, welcome everyone here in the room and also online. It's my pleasure to introduce our speaker for today, Professor Marie Carlton. And I know many of you know Marie. You may not all know that she's a proud New Jersey native. I didn't know there was such a thing. Marie can convince you. I guarantee you, she will convince you. There's a reason to be proud of the Garden State. You can ask her about that. But she was born, raised, got her PhD, taught at Rutgers, and then Irvine was able to pull her over here to this side of the country, fortunately. The last year, she was pulled back to the East Coast, but we have her back now. And so glad to hear a bit about what's been going on lately. So thanks, Emily.
Thanks, Alex. So I'm going to talk to you today about air pollution from agriculture. I actually studied agricultural engineering as an undergraduate. Nobody knows that. And it's a play on the Farmer's Almanac. So first things first, like Alex said, I'm so totally and completely from New Jersey. And when I moved here, I needed to develop a West Coast perspective on air quality. And so I go searching for images like this one. And this is absolutely my favorite. This is Los Angeles pictures from the same exact location in 1954. That's 16 years before there even was an environmental protection agency. And then Los Angeles today. And if you can't see, this guy in the car has like a nice really nice touch. And so we often will pat ourselves on the back because air quality has improved dramatically. I just showed you that photograph. We can't use snapshots in time to robustly evaluate trends, but we can look at time series like this. And so what this is showing is the mass concentration on the y-axis, and then the x-axis is time, and it's showing you the decrease in fine particle pollution over the United States, and it's gone down quite a bit. But that's a little tiny bit misleading. So that average for the whole US is 37%, is largely driven by 3 regions in the United States. So the Ohio Valley, the Southeast United States, and that's where a lot of power plants are. So in the Western US, we have these nice latitude and longitude markings, but in the East Coast, we use rivers, right? That's why those lines are squiggly. And so most of the coal plants in the United States are on the East Coast. So when the United States EPA started implementing environmental regulations, they attacked coal plants first. It was politically palatable. And then air quality in the eastern US got better. So the Ohio Valley, Southeast, and then downwind of those 2 areas, the Northeast. And so that average for the whole US is driven really by these 3 areas. And so air quality very much remains a domestic issue. And so this is a photograph of Angel Stadium. Now you might know exactly where this is. So when I talked to my nephews, when I heard this video, they were like, what's it like? And I told them it's magical. We have disappearing mountains. And I showed them these pictures. And so what I want to point out is air quality is still a domestic issue in the West, and in particular, agricultural areas are being behind. And because this is air system science, I will point out that I'm pretty sure there's supposed to be water here, but Alan travels on sabbatical, so we'll okay, so most of this fine particle mass forms in the atmosphere. So there's emissions from different sources that are in the gas phase, they undergo chemical reactions, and then they go into the particle phase. So I'm going to show you some pictures of New Jersey. This is a beautiful, I don't know, the image is not, it's like being absorbed by the background. That's a Delaware Gap in New Jersey. I thought that I understood traffic. This is the New Jersey Turnpike, which is smaller than this exit ramp for the 405. And so California has this really strong environmental reputation. Alex alluded to New Jersey's environmental reputation, but I mean, compare New Jersey and California, right? These fires and highway, right? New Jersey is also pretty big. We also have emissions from clouds and power plants, fires, things like that. And then these emissions form particle phase pollutants. And so I really love this figure. So if you're active in atmospheric, she's going to take you a second. This is from 2004 and it's not the AMS colors. So each location is a sampling location in North America. And then the size of each circle is proportional to the total amount of fine particle mass. And each color of the pie is a different chemical constituent. So the yellow part in the East Coast is sulfates. One of the things I want you to take away is, we might point at developing countries like Mexico City, and clearly there's a lot of pollution there. There's a lot of pollution in Fresno too. It's on the West Coast. And the other thing I want you to see is that on the eastern side of the United States, a lot of those pies have very big yellow pieces. And on the western side of the US, the yellow parts are less prevalent. And so that's what's driving the PM2.5 mass decrease across the United States, is the acid rainfall. And so it's one of the things I really love when there's this policy EPA, it's like we're going to do something about acid rain, and then accidentally they reduce PM2.5 pollution. So what I'm showing here is just a map of deposition pH values. And so you can see on the left-hand side it's more red is bad, and the right-hand side is green, and green is good. Okay. So how do we get this formation of particle mass? And mostly, predominantly, it's the formation of salts. So you have emissions of SO2, and then I don't want to get too into the weeds about it, but SO2 will go on to make sulfuric acid, and then you get base, and so you make ammonium sulfate salts. You have emissions of NOx, they go on to oxidize and make nitric acid, they get base, and then they form ammonium nitrate salts. And that's how you get that transfer from the gases to the particle phase. So now I am using the AMS colors, and this light blue part, I talked to Doug Worsnov and Jose Jimenez, and this can be the official aerosol liquid water color. So we're going to make your next class. And so this is set up just like the other ones. Each pie is for a location, and then each color of the slice is key to a chemical constituent. And so what I want you to take apart, what I want you to take away is that the red part is sulfates. And the thing is, you can't make the sulfate part without the orange ammonium parts. The dark blue part is nitrate, and you can, but it's really difficult to make that dark blue nitrate part without the ammonium part. You definitely don't make the water without ammonium, and some fraction of that green part also needs ammonium. So ammonia is really, really key to forming particle matter in the United States. And so where does ammonia come from? It mostly comes from agriculture, and it mostly comes from livestock waste. Melissa Burns made this slide, I don't know if she's here. But anyway, this is from the National Emissions Inventory. And when we take all the source sectors and add them together, ammonia from livestock waste is still a factor of 3 higher than all the other sources added together. Okay, so let me tell you a little bit about ammonia from a policy perspective. The Environmental Protection Agency regulates ammonia under CERCLA, that's the Superfund rule, and it also regulates it under EPCRA, that would be like right to know, except when ammonia is present on a farm. So you can have like a barrel of ammonia at a place, it's regulated. You take that same barrel, put it on a farm, it's not regulated. You take that same barrel off of a farm, it's all of a sudden regulated. That's crazy, right? In 2006, EPA entered into this final order with the CAFOs. CAFO is a concentrated animal feeding operation. And any CAFO that paid, if you ask EPA, it was a penalty. If you ask someone from the CAFO, they would tell you, no, we contributed to an emissions study. If they contributed to this, then they would be protected from any civil liabilities and violations of environmental regulations. And that study is supposed to take 2 years. It's 2022 right now. I don't know, you guys are students, they're younger, and they tell me 2006 was a long, long time ago. And these emissions are still not final. EPA's own Inspector General has publicly asked twice if EPA would rescind the order, but they haven't. In 2008, the Government Accountability Office released a report and said that EPA needs data to regulate CAFOs. So the data is hard to get, and I'll go into that in a little more detail. NEPA, the National Environmental Pollution Act, is kind of the Magna Carta of all environmental rules in the United States. And NEPA has language that specifically exempts agriculture and CAFOs in particular from requirements. And also federal agencies are allowed to do these things called categorical exemptions under NEPA. and USDA almost always grants CAFOs, these categorical exemptions. The 2018 Farm Act exempts farms from any self-reporting requirements for animal waste, so you can't force them to report. And there was 2 riders in the Appropriations Act and the Omnibus Bill that prohibited use of funds to issue air permits for several pollutants or require greenhouse gas reporting from animal manure management. So, when I was at EPA, I was like in every USDA is on a whole other level. They have lobbyists and they know what they're doing. And so how does this happen? Why, people are reasonable. When you talk to individuals, they're reasonable, right? We don't want there to be poison in the environment. And I think it comes down to this, when we think about farms, we have these bucolic notions. You look at these cows, they look really happy. They're probably just back from the sauna, gonna go get earlier. But that is not what farming is in the United States. Meat production in the United States is export focused and it's agribusiness. And we have these vertically integrated giant things. And so this is a traditional hog CAFO in North Carolina. This is a chicken CAFO in Delaware. This is a cattle CAFO in California, and this is a dairy CAFO in California, and those are the ones. So this is what I wanted to work on. This is why I went to DC. Okay, so Alyssa's here now, and so she made a lot of these talks. Things that we started to learn. The USA Census of Agriculture is available every 5 years, and it defines these large-scale operations: 500 or more beef cattle, 500 or more dairy cows, 1,000 or more hogs. 500,000 broiler chickens sold annually. This is a large operation. But the thing is, from the Census of Agriculture, the largest CAFOs are missing. So if a CAFO in a rural community takes up more than 50% of the land area, then they're not required to be listed in the census, because then you would know who they are. There's all of these privacy issues. And when you try to play backwards, we say they seem to know there has to be privacy. However, those issues are not unique to agriculture. There's lots of oil and gas wells that are on personal property. Okay, and then really quickly, the USDA large category corresponds to EPA's medium CAFO definition. EPA roughly defines an animal as 1,000 pounds of live weight. So that's an individual cow, basically, or 2.5 hogs, or 125 chickens. And so what we did is we took county level numbers from the Census of Agriculture and link them to their specific land areas from the Economic Research Service using the Census Service unique ID for each county. And then we also went into EPA's National Pollution Discharge Elimination System, NIPDES, because some states report numbers. And so here on this x-axis is time, the first y-axis is the number of CAFOs, and it's blue, and then the red line is key to the secondary y-axis, that's in red. And so the red line is animal numbers with a lot of significant digits. And then the blue line is the number of CAFOs. And so what we see is that over the last 20 years, last 2 decades, animal numbers have some variability, but they're not really rising. But animal density is rising quite a bit. And I think animal density is the key. So I live in Union Hills on a cul-de-sac, right? There's maybe 14 homes in that cul-de-sac. Like if each house had one dog, you probably wouldn't smell it. If all 14 dogs are in one backyard, you would smell them, right? You would be able to smell them a lot over. And so that's what we're showing here. We're showing animal unit density across the United States. So the hotter the color, the higher the density. And so what we can see, and this is just with every 5 years of data, not including large CAFOs, we can see that the animal spatial distribution is becoming more consolidated. This is the number of cattle. Keep your eye on that arc in the Midwest. This is the number of dairy cows, the Central Valley pops up. This is the number of hogs. The US EPA has a civil rights action against the North Carolina DEQ right now for hogs, and then also the Midwest. And then this is broiler chickens, and President Biden's home state of Delaware has the most broiler chickens. So here I'm showing you is NASA's 21st century science and technology is making it more and more difficult for pollution to hide. And so this is remotely detected ammonia from outer space. There's a machine floating around outer space. Measurements, it blows my mind. And so here, the hotter the color, the higher the ammonia mixing ratio. At the top is spring, March, April, May. The second row is the summer, June, July, August. The fall is September, October, November. And then the bottom row is the winter. And so what we see, that arc over the Midwest looks a lot like that arc in animal unit density. The projections of the Earth are a little bit different, so it's a little bit different. And the thing I want to highlight is that there's this very sharp decrease from the summer to the fall, and that coincides with the animal slaughtering. So the conventional wisdom, at least in the atmospheric chemistry community, seems to be, its application of fertilizer, which happens in the spring. And that's absolutely plays a role, but we have this sharp decrease in the fall, and it's because a lot of animals in the fall. Okay, so while I was in DC, the State of the Year came out. So the American Farm Association puts out the State of the Year every year, and they listed the top 5 cities that are most polluted in the United States for fine particulate matter. So it's Bakersfield, California, Eisenhower, California, Fresno, California. Everybody goes to Tavern, San Jose, California, Los Angeles, California. And then the thing that was crazy to me is in the previous year, Americans experienced more very unhealthy and hazardous air quality days than ever before in the 2 decades of the city report. And then here are the PM 2.5 non-attainment areas. There's 2 serious ones, one in Los Angeles, one in Silicon Valley, and then there's one. So in the State of the Air report, they blamed the poor air quality in California due to wildfires. They said, there's higher frequency, there's greater severity, there's longer duration, and that was why we had these elevated year-round levels. And I wanted to see if that was true. So here, this is just a different plot of ammonia. This is an average of over a year. This is from the European High-ASI product. The deeper the blue, the higher the ammonia concentration. And then those orange circles are the cities with the highest PM 2.5 concentration. And so we see this deep blue dot over the Central Valley, and that's where the 3 most polluted cities are. And so when I went to the coordinates of that grid cell, there is a dairy. So then I wanted to see, okay, is that true? There are some place speciated measurements. And so it was actually really fun. I was in DC, my boss was Jane Lochenko, and she asked me this, but we were talking through Twitter. So I made this plot when I tweeted it at her, and then she tweeted me back some questions. But so here what I went, I got the chemically speciated CAM data from Kern, which is in the Central Valley. The x-axis is time, the y-axis is mass concentration, and then the blue line is the nitrate concentration. And then in the late 1990s and in the early 2000s, when EPA was launching its PM 2.5 network, there were a lot of studies in California where people were arguing against the use of certain types of filters because of nitrate losses. And so actually nitrate loss from particulate matter filters in Central California is actually really well characterized. And so I took equations from a paper by Judy Chow and I applied them to the measurements. And so that shaded blue area is my lower bound estimate for how much nitrate was lost. And then that green line is organic carbon. Organic carbon can have a positive or a negative artifact, since I made that line a little bit bigger. And so organic carbon is certainly not helping, but I don't think that's what's driving the air quality problems in the Central Valley. Okay. So agricultural emissions also affect climate. EPA reports that agriculture is the largest source of 2 greenhouse gases, nitrous oxide and methane. Methane from agriculture is not regulated. It's exempted from the president's methane pledge, and it wasn't discussed at the recent COP, which is personally disappointing to me. Nitrous oxide is also an ozone-depleting substance that has the fastest rate of growth, South Pole. And nitrous oxide is not covered under the Montreal Protocol or any of the later agreements, such as the Cabell Agreement, which Congress ratified this year. Greenhouse gas emissions from agriculture are actually rising. You hear people talk about like, oh, the US is emitting less carbon dioxide, and that's only true, for certain industries. So here, this is from the EPA, and the blue pie is the different sources of methane. And so enteric fermentation, that's burping. And then manure management, that's agriculture is the largest source of methane, followed by natural gas, petroleum systems. And then in the bottom, I'm showing a time series of methane emissions from agriculture, and they're going up. So I made this plot for you very quickly. And so this is a fraction of US greenhouse gas emissions that are coming from agriculture. And it's increasing. Okay, so this is another issue that I care a lot about, environmental justice, and the Biden-Harris administration has this Justice 40 initiative. We've got 40% of all funds need to be spent in traditionally marginalized communities. And so it was during the pandemic, and this picture from the Sacramento Bee, and it was about farm workers during COVID, and there was epic wildfire, so the air quality was really poor, and they were out in the fields, and I had berries in my cereal, and I felt like a jerk, and I was like, who speaks for them? And I work in Roland Hall, and there's this quote in Roland Hall, like, if not us, who, if not now, when? And then that's when I applied for the fellowship. And the thing that that challenges me emotionally maybe is if we think about our most ambitious environmental plans, like if we decarbonize the grid, everything, air quality in the Central Valley will still not get better. And that's not fair. Migrant and seasonal workers are among the most vulnerable in the US and globally, and they hardly have a voice. There are entire academic journals devoted to studying the weird kind of diseases that ag workers get. It's just unjust. So OSTP let me fly the SARP. So you might recognize the Mon Lake in the middle. You might recognize Raph and his NASA pajamas. And I said I convinced SARP to do some flights focused on dairies, and they were like, go ahead. But that was the work to understand the flight planning and the work to do the politics around that. They're equally hard and equally clear. So on June 23rd, we had a 7-hour flight in the DC over California Central Valley, and I didn't puke until hour 6.5. Rain on June 22nd, scavenged tree species, so the atmosphere is actually really, really clean. And why I want to go to Central Valley, I think that explains to you why I want to go to the Central Valley. It's one of the most productive agricultural regions in the world. It has a large amount of CAFOs. It also has oil and gas wells. It's home to the most polluted PM2.5 seas. There's lots of ammonia. In California, specifically, the odds of exposure to CAFO pollution increased with increasing percentage of Native Americans, non-Hispanic, Blacks, and Hispanic individuals. So we measured methane. We had a bring down analyzer. We had 586 methane measurements that passed all the QA and QC. And then what I wanted to do is I ranked the measurements. So for the students, I have a very biased sampling plan. Michael Prather's ACP paper, Justifying the Atom Campaign, like we'll explain to you why this is a problem, to have a biased sampling plan. And so what I did was I was like, I'm going to rank all of the data in order of highest measurements to lowest measurement, and then explore the bottom and top quartiles to see where they are truthfully. And so I'm going to show you the coordinates corresponding to the top quartile and the bottom quartile. And a further constraint is that any measurement that was in the lower quantile, I also screened it so that it had to be below 500 meters. So I didn't want it to just be a loft study air. I wanted it to actually represent clean air. So this is our flight plan, and you can see the spirals, and that's not really cute. It's like while we're coming home. So half of the measurements in the top quartile are unambiguously associated with CAFOs. So what I did is I took the coordinates and I looked at each individual spot in the borders. And then 3 of the top quartile measurements are actually above 500 meters. I didn't have that constraint for the top quartile. So that's actually very, very clear there because it's high up. And then no measurement in the bottom quartile is associated with CAFO. So here I'm just showing you that same map, but key by color. And if it's bold, it indicates a CAFO. And then one of the other things you can see, we have the mountains on the eastern side of the country. I have lower measurements, east of those hot spots, but west of the mountains. So it's not that the air was getting blown up and I was measuring the highest concentrations against the mountain. They're really over Caicos. And I think it's because it rained the day before and was so clean, so we were able to see spatial effects. So this is an example of where the highest measurement was. And there's 3 dairies in this picture, and you can see their lagoons. And then it was like exciting because then our press office was talking to NASA's press office and they tweeted about it. And 5 million people saw it. And so I really want to thank, regulating air pollution from agriculture was not a Biden Harris administration priority, but they let me go and do this, and I'm really grateful. Okay, so if you take away anything from my talk, it's that air pollution from Caicos degrades air quality, it exacerbates environmental justice concerns, it contributes to the climate crisis. Air pollution from Caicos is not federally regulated, and so there are states and local communities that want to take action, and they're hindered by that consent decree from the EPA and also by NEPA, and that's not fair. And then air pollution from Caicos could be federally regulated, and this is with Justice 40 goals and protecting health. Okay, so I wanted to tell the students a little bit about what I learned and what science skills I think translates. Be uncompromising in your pursuit of depth of knowledge. That applies anywhere you go. It applies when you're doing a PhD, and it applies when you find yourself in some other environment. Doing literature searches, conveying that you understand the detail really, and actually read the reports and follow through. Those are skills that will help you in academia, and those are skills that will help you if you decide to do a policy career. There are lots and lots of smart people in the world. So never take yourself too seriously. Everyone you meet knows something that you don't, and you can learn from them if you're open to it. So being able to work with other people is really critically important. Individual credits for accomplishments is overstated in a place like DC, but it's also perfectly correct. So something will happen and you'll hear a dozen people take credit for it. And you're like, wow, how could that be? But I think, change is so hard that it really does take like hundreds of people pulling together in the same direction for things to happen. So it's like, it's overstated and right. And so now I'm about to do that. So I can't say because some things haven't come out yet, but my time there, I really do feel like I made a difference. And there's some report coming out from the Biden Harris administration that now has a livestock management plan, and it didn't have that. And so I called my boss and I was like, I wish you were here so we could jump up and down the hallway together. Okay, I'm going to thank everybody. Independent federal science safeguards human health and the environment. And then the data I presented here is data from NASA, NOAA, and the White House Office of Science and Technology Policy. Kara Burkhardt is a young activist who first taught me about Caicos. That's my son, you see me, and maybe kiss, and that's Alyssa, who interprets everything. And then I just want to show you some quick pictures. All right, where to start? So this picture on the top left, that was my first day. It's like the EOB I worked in the Eisenhower Executive Office building. That's telling me where to go. And then there's 2 pictures. That's the new press secretary, here. And then in the other picture, you can't see her, but it's the old press secretary, Jen Psaki. And her hair is so amazingly red. You can see her from a mile away. So to see her every day was like very exciting. So when she was stepping down, I'm like, oh no, I'm never going to know that I'm seeing someone famous again. And then like a week later, I saw Kareem and I was like, oh, you're right. That's for me. One of the things that's really interesting is like the basketball team that wins the NBA will come and visit the president, and then they'll bring the trophy and you can take a picture with it. So I'm going to do that one day, but like sometimes it's the AIDS, the original AIDS quilt or something else, and it's just pretty wild. So in the black and white tiles, the black is limestone and there's always fossils in it. And then behind the president, he was just like in the office one day. And he took a selfie. That's my friend Harold. And so Harold would see me in the hallway often, like looking at the tiles, and he would tell people like, oh, maybe you're gonna fall into something, and he would say stop something. There's a train underground between the house and Senate. I got to ride it one time. At Christmas time, the president wrote us an email and he said, Dr. Biden spends a lot of time in Christmas decorations. I want as many people to see them as possible. And so whenever he's at the building, he could have a lottery, and I won the lottery one day. I got to go and I had on my Christmas pants. So I was very excited. The second gentleman did a March Madness thing, and then there was a reception on his balcony, and there I was with my friends on fire. And then so when you're walking around the building, it's just like you randomly see a sign like, oh, director of the Central Intelligence Agency's office, or office of Madam Vice President office. And so I have a bunch of random selfies like since he's like, and it's funny, I was talking before about at your house. When I first went to go get my flu shot, and it's like these Navy SEAL doctors, and he's like, oh, you're one of the scientists, aren't you? And I felt like, how could you tell? And I look at pictures like that, and I'm like, yeah, that's how you tell it. And then finally, the president also does this thing where he gives out these lotteries for when Marine won returns. He likes to say hi to the federal employees. So like that crowd behind in the back is actually the press, and he sometimes says hi to them, but he always does this. So I never won the lottery, and then the week I came home, I won the lottery 3 times. And then my friend Phil got to go, and I was like, what was it like? And he was like, this is what it was like. And so we always had these plans for what we were going to say if we met the president. And I was going to say was, you said you're going to make up monopolies in the industry, there's a lot of monopolies, right? But that's not what you say. I asked him what he said. I was like, I said hello. I'm probably over time.
We could.
Right, thank you for your time.
Questions for Anne-Marie?
So you said that the meat market in America is primarily for export, and I just wondered where are we exporting our meat to?
Yeah, other places. I'm not really sure, but it's an increasingly bigger and bigger fraction, and most meat is exported. Actually, it's not just meat.
I know that we've been exporting pork to China
Okay.
for some time, and that's probably growth.
Yeah, that makes sense.
Very nice call. I'm just curious, like when you're talking about density of the lab stuff,
Yeah.
why did density really matter? Can you elaborate a little bit? Is it about regional air quality or?
Yeah, so I have a couple ideas on that. I think increased use of silage plays a role, how wastewater is treated. There are some CAPOs that generate more wastewater than the city of Philadelphia, and they're not required to treat it. Can you imagine if the lady didn't treat wastewater? And so I think there's certain practices that are sustainable and easier to implement at a smaller farm. Like, the soil has a certain carrying capacity, and you need to put all those animals together and start to see that. But then there's also like direct movement practices like the slurries and the silage and how you see those. Michael?
Remember you went after ammonia.
Yeah.
What about nitrogen oxide, VOCs, nitrous oxide, all the other pollutants that are coming off of a lot of these waste management plants?
Yeah, no, those are really good points, and that's maybe what's driving people more sick. The reason why I was going after ammonia is on this mission for EPA to make ammonia criteria document. Criteria document just like SO2, because it kind of does the same things, and so or it could be regulated for the same reasons. And so I thought like that regulatory framework already exists and would be relatively easy, simple but not easy to implement. And so that's why I focus on ammonia.
So ammonia is not really listed anywhere, either criteria or greenhouse gas, etc., whereas all the others tend to be out of criteria.
Yeah, and so they're on. So then those other pollutants get these special exemptions, and ammonia is like not listed anywhere. And so it was like, probably was playing spy versus spy. Hi, Jim.
To what extent is ammonia deposition becoming an increasing national problem?
Yeah, that's absolutely right. And so John Walker has some papers on that where he's looked at the deposition network, and it does look like that ammonia deposition is rising. So yeah, it's going to, and the extent to which that impacts ecosystems, I have kind of a fifth grade understanding of that. I think that's fascinating. Hi guys.
Hi, Emily. Thank you for the talk. I learned a lot.
Oh, good.
And I'm thinking about, I'm trying not to feel too disheartened with all these like exemptions that our industry gets. And I'm wondering if you could provide a little context on, you know, the atmosphere has no boundary, right? So those pollutants that are emitting from the agricultural sector go elsewhere and cause problems. So I'm sure that some of the NGOs have tried to sue them, right? That's what they do.
Yeah, if they're part of that consent order, they're exempt.
They can't still be sued. Okay, so then my next question is, how does it change? How do you remove those exemptions?
Yeah, you get a fellowship in the White House and you can talk to people every day and learn about it. That's what I try to do.
Are you hopeful for the future?
So Michael Regan is from North Carolina and he started a civil rights case against the DEP of North Carolina for issuing legal permits that he thought was issued. And so that's a really hopeful sign. You know, there's a couple times where maybe sometimes things aren't going well and then they're like, oh, can we do something easy that changes the news cycle? And so an idea that I frequently had was we could ask the EPA to get rid of the consent decree, and that would be really easy. And then EPA doesn't even have to do anything. Local agencies could, local NGOs could, and then you know, those conversations go, okay, this is a good idea, and then nothing would happen. So I don't.
Other questions? Not, let's thank Anne Marie.